Today, we'll take you through a journey through the breadth and depth of AWS observability. We will also have an exclusive sneak peek on how Joe, an amazing technologist, becomes the employee of the quarter. My name is Arun Chandapillai, and with me today, I have the most amazing Lucy Harton. Lucy, please take it from here.
Awesome. Thanks, Arun. My name is Lucy Hartom. I'm the Worldwide BD Specialist for Observability. Today, we're going to cover an overview of application monitoring by using Amazon CloudWatch. Arun is going to dive deep on sharing a latest capabilities around application monitoring within CloudWatch. And we're also going to help you get started with our one observability workshop and wrap up with some resources that you can take away after at the end of the session. So with that being said, let's start with a Gartner's definition of APN. I'm going to take a quick 30 seconds for you to read over. When we're talking about APN, we're really looking for visibilities into end-to-end of application, not just at the application layer, but also the supporting infrastructure as well as the application performance impacting the end users. In today's environment, let's be honest, applications are complex. A lot of our customers or you are building applications in the distributed environments. And this leads to many areas of visibilities are hard to tap into. We all understand why you're building that in application in a distributed environment. And however, gaining visibilities become a key challenge for our customers. How are these applications built underlying with microservices? Which one are dependent of each other? It's always a mystery to our customers. Over the years, customers has expressed these common challenges when it comes to APN. First of all, the architecture of today's environment is very complex. How to really understand what is what, which one dependent on which, it's it's often customer wants to get more visibilities into. Then try to stitch different telemetries signals together to really understand how the application is performing. Various different microservices generate different type of metrics, but doesn't often translate into application performance. And let's just assume you have figured out the first two. A lot of customers express that they just don't know when there's alarms being triggered, which one is most business critical one that they need to address or pay attention immediately. So be able to really differentiate that, it become a challenge. So which leads to alarm fatigue, which leads to sometimes you just miss the most important alarms and then issues that you need to fix. And then lastly, customers have said to us that a lot of times they are using different capabilities in APN, whether it's using synthetics monitoring or whether use trace, but not in a very joined manner. There's no single pane of glass that the customers are really be able to tell their application performance overall. They have to go many different places, try to, again, correlating these information together. So very disjointed experience for our customers. Guess what? We hear you guys loud and clear. So we're very excited to talk about this new capability that Arun is going to dive down deeper in the later session to really try to address these needs. First, is a capability have help you discover various different resources or microservice underlying the application. And that's going to help you understand what are the components are building this application, what's its dependencies are, make it easier to really understand the view of the architecture of the application. Secondly, we want to standardize that metrics into application language, right? What are we really care about in the application performance? We determined a couple of golden signals like volumes, availabilities, latencies, false and error rates. And these are important in terms of application performance, and we want to be able to translate that for you. The next one is setting your own SLOs. A lot of customers telling us that in order to meet their SLAs, they need to set their own SLOs. Every company are different. And how are you we be able to help you in that area to customize and be able to help you prioritize which one is most mission critical issues and you need to address. So capabilities of setting your own SLOs. And then last but not least, obviously ease of use, right? We want to be able to give you a capability or solution that you can really get down to the root cause of the issue in 3 seconds. And that's something we really excited to share with you today. Here are some common use cases our customers are telling us in the APN. First, the obvious one are analyze and debugging applications. So certainly you want the two sets and the services that for APN is to understand how your application performance and how you can go fix the issue when there's issue occurred. Secondly, we also have tight integrations with our infrastructure layer to really provide you of the end-to-end container observability if you're currently building applications in our container environment, specifically in EKS. And Arun is going to show you a little bit more in the demo. And then last but not least, SLOs. Capabilities that you're able to create your own SLOs and be able to monitor against your SLOs and be able to really pay attention to what's most important issues overall. Now we kind of tie back to my first slide, talk about Gartner's definition of APN. And here are our view of 4 different layers that really covers end-to-end observability in the application monitoring piece. All the way start from the network layer to the digital experience. And we often hear at the network layer, people say, hey, is this my network issue or is this my application issue? So to have visibilities in network layer is important, and it's impacting your application performance as well. Infrastructures, what are the infrastructures your application is built on? Whether it is the containers, serverless, computers or servers, are there have enough memories capacity to support your application traffic and volume? That is very important to understand and determine fact and impact for your application performance as well. Obviously, the obvious layer applications. And let's not forget about the digital experience. Their users who are interacting with your applications today. If they cannot access your application, if there's a delay, that is result in the poor user experience. We certainly need to take care of those issues as well. So those are 4 key layers that we care about in terms of application monitoring. And here is what we want to provide you a deep dive in our latest application monitoring capability, application signals. This service was announced in reInvent last year, currently in public preview. So we're very excited to give you an inside look of how you can leverage the service, our new capabilities for application monitoring. But before we jump into the deep dive session, we also want to pointing out that our native observability service, CloudWatch, has all the depths and breadth of capabilities, not just at the foundational level, logs, trace, and metrics. Oftentimes, I get on call with customers. Many customers are familiar with Amazon CloudWatch logs and trace and metrics, but they often forget or not realize there's all other capabilities above the foundational that we offer, right? We can have various different dashboards to surface the insights. You can leverage cross account observabilities, as well as we have invested a lot of capabilities in the insights and then analytics space to really surface these insights in the observability space for you. So I want to share this slide to give you an overview of what is our native observability capabilities are, but with a key focus today on application signals. With that being said, I am going to turn over to Anum to on application signals and then deep dive.
Thank you, Lucy. You are always amazing. Now, application signals. In one sentence, application signals automatically collect the golden metrics. And what are those? The availability, the volume of requests, latency, and fault and errors, all of them. And then traces from your applications, enabling you to quickly see and triage operational health without writing custom code. Yes, without writing custom codes or even creating custom dashboards. It does all of that for you. Now, let's break that down and see how application signals will be your next best friend going forward. First and foremost, application signals provides pre-built dashboards. They are optimized to present the most important operation data all in one place. It discovers your services and makes it easy to spot anomalies and allows you to dive deep into the services and inspect the dependencies. The next one, the golden metrics. The four, availability, the volume of requests, latency, and faults and errors. All of them are discovered out of the box for every service, for every operations, and for every dependency. And that's simply amazing. Now, the third one, service level objectives, which is my favorite, also known as SLOs. These days, application owners use SLOs to set goals based on business and customer expectations. With application signals, you have a native way to set, monitor, and report on SLOs all in CloudWatch. Lastly, application signals correlates your important telemetry data. This allows you to go from the golden metrics to correlated traces and arrive at the root cause of an incident, all in just few clicks. Today, application signals, as Lucy was saying, is available in public preview, and it supports applications written in Java today, but very soon we'll have several other languages getting supported. Now let's see how it works. On the left side of your screen, you will see a Java application that is running on EKS or EC2. You are not required to make any code changes in order to get started. All you have to do is configure the unified CloudWatch agent, which unifies the setup of the CloudWatch agent and the ADOT all in a single step. For EKS applications in particular, the CloudWatch agent can be enabled on your cluster as an EKS add-on. After enabling the add-on, the A.Java agent auto injects the OTel auto instrumentation library for Java. Now, once this is complete, it starts sending your data to Amazon CloudWatch and AWS X-Ray. Now then, the application signals automatically discovers all your services and the dependencies and provides application topology visualizations to understand the state of your application architecture. Today, we will dive deep into a day in the life of Joe. Joe is a seasoned professional. He's an application owner and he's very thorough in everything that he does. Joe is the owner of an application called Pet Clinic, and you are seeing that application. It has several functions. People can register their pets, people can go and schedule a doctor, so on and so forth. It is written in Java, deployed in EKS. It's a beautiful Monday morning, and Joe is stepping into the office. Just like most of us, Joe likes his Fridays far better than the Mondays. And I guess you know what I'm saying. Now, as soon as Joe was in the office, there was a message in the Slack. It says customers cannot schedule visits to his prestigious application pet clinic. Now, Joe knows that that's not great, right? And it's a Monday morning. What would Joe be doing? Joe logged into Amazon CloudWatch, and then he went to application signals, and from there he clicked on services dashboard. Joe was looking at all the different services that were discovered automatically by application signals. In this case, customers cannot schedule the visits. That's a problem. And as Joe was looking at the visits service, uh, application that was discovered, Joe could see that there is something unhealthy. A status, an SLI, or a service health is not good. What was Joe doing? Joe would click on the visits service. There, Joe can immediately see that the availability of his application looks good when the volume is steady. But when the volume spikes, the availability of his application drops. And that's not good. The volume and availability kind of is going, crazy. Joe was thinking, what is wrong with my application? Now, Joe knows that whenever the volume spikes, his availability drops. So, what is Joe going to do? Joe clicked on the point where the availability dropped. As soon as he clicked on it, the system now focuses on all the traces for that point in time. Now, from there, Joe clicked on one of the traces. As he was looking at the traces, he could see that the calls are going to the backend DynamoDB table. Joe is checking the segments of his call, and he could see that there is an error all the way down. Joe clicked on the DynamoDB table, and now he's going to dive deep into the segment. He's going to dive deep into the segment details. There, he's going to check the exceptions if there are any. He clicked on exceptions, and then he could see that the level of configured provision throughput for the table was exceeded. Now, Joe now knows that when the volume increases, his application is not provisioned enough from a capacity perspective. Joe immediately called his infrastructure team and told them that we have to do a scale out of the DynamoDB in such a way that we provision a little more throughput capacity for it. Joe is happy because he was able to troubleshoot the first problem that was reported to him. Because it was a Monday morning, Joe badly needed his coffee. He logged his computer and he was stepping away to the cafeteria to have his favorite coffee. At that time, at that moment, the pager went again. This time, the second incident is the sign up to the pet clinic is taking too long. And that's not good because it's directly connected to revenue. If new customers are not able to sign up, that will affect the profitability of Joe's company. Now, Joe has no other option but to log back in. This time, from CloudWatch, he goes to the service level objectives dashboards, which is part of the application signals. There, Joe is looking at the different service level objectives that are already created. He could see that there is a latency for registering an owner, for new owners, by the way. And he was looking at it and he could see that the error budget is off the roof. It's going crazy. Joe scrolled to the right and he could find that specific operation that is responsible for that action. He clicked on that operation. Now he's looking specifically at that operation for registering new owners. As you could see that Joe was able to find that the availability of that operation is pretty good. It's right there. He could see that the faults and errors, there is nothing. Then what is going wrong? The latency. So, as a matter of fact, not all customers are facing this problem. Few of them are not able to sign in. And as Joe was looking at it, it's only the P99 that is getting affected. The rest of the latency is kind of okay. Now, what did Joe do? Joe clicked on the P99, which means the very few that are having problem. Now, what application signals does for you is it focuses on that very few problems, right? Now, Joe clicked on the trace ID to see what is happening for that particular slow P99. As Joe was looking at it, he could see that the clients are coming in, but there is an error on the payment gateway. Now, for Joe's application, they actually uses a third party payment gateway service when the new owners are registering, like getting the credit card or the debit card number. Joe scrolled down and see what is happening, and Joe could immediately figure out that the third party call, which is to this, uh, which is to Joe was clicking on it, and the third party call to the payment gateway was having a 500 error. Now, Joe wanted to call the third party and complain that it is your problem. But Joe is not an average Joe. He's splendid. He's a technologist. He's an amazing person. He wanted to make sure that his infrastructure is also good. What did Joe do? Within application signals, Joe was able to find the backend infrastructure on which his microservice is hosted. He clicked on under hosted in the customers dash service. Right now, application signals is taking you all the way to container insights. Amazon CloudWatch Container Insights collect, aggregate, and summarize metrics and logs for your containerized applications and microservices. As Joe was in the Container Insights dashboard, Joe scrolled down to see something amazing. Joe could see the cluster, the namespace, the workload, and even the pod on which his particular operation is running. And here you could see even the process ID. And that's pretty cool. Joe was looking at the CPU utilization, everything good. Joe was looking at the memory utilization, everything good. And as Lucy was saying, network. We always blame it on the network. But here we go. Container Insights even brings you the ingress and the egress, and everything looks hunky dory. Joe wanted to troubleshoot it a little further. Joe scrolled all the way down, and Joe now wanted to check the logs. Container Insights allow you to click on that particular service and click on View Application Logs, and it takes you directly to Amazon CloudWatch Logs Insights. Here, the product is so good that it even gives you the query. As the screen comes up, you will be able to see that it pre-selects the particular log group, and even it gives you a query. Joe could easily run the query to see what is happening. Now, Joe is smart. Joe also wanted to check what is happening if there is any particular pattern. Container Insights allows you to click on the patterns and click on if there are too many errors happening, if there are any errors at all, right? And Joe also wanted to troubleshoot it in such a way that he wanted to compare it with the past or the previous days or the week's data. Joe easily clicked on compare of and then clicked it on a previous week and then applied. Right now, he would run that query again. And in the pattern, as you can see, there is a difference event count and a difference description. Now, Joe was able to see that there is a 40% increase error compared to something else, or a 4% decrease compared to the previous week. Now, looking at all of this, Joe could easily say that it is not his problem, but the third party payment gateway. Now, Joe made a call to the third party payment gateway and asked them to check what is happening at their end. Joe was a happy Joe, I would say, because he was able to figure out exactly what was happening on that particular issue. This time, Joe really needed his coffee. He locked his computer and he was walking away. At that time, it was not his pager this time, but it was his cell that that was ringing. The DevOps team called Joe and said that they have pushed a new release to production and they are not sure if all of the dependencies were working. Joe was like, not again, and that too not on a Monday morning. How can you do that? But Joe has no other option because he's the owner. He came back to his desk. Now he wanted to go back to Amazon CloudWatch application signals service map. He clicked on the service map. This time, as you can rightly see, Joe was able to see how well his service was distributed. My friends, this is something that is auto discovered. Joe has, he had nothing to do here. It was auto discovered by application signals. Joe really knows his product. He was scanning through all of this and then he found out that this new call that is made to the SQS, probably that is the culprit because he has not seen it before. That is probably the new dependency that the DevOps team is worried about. Joe clicked on that link and it immediately did bring a pop-up. He was looking at any faults, the latency, nothing bad. But this took his attention. He could see that this particular service, customer service, has an error rate, and particularly on the operation purge queue. What did Joe do? Joe clicked on that particular service. As of right now, as you can see, application signals is focused on the dependencies right now. Joe was looking at the volume, traffic, and all. It's all pretty good. There are a few dips, but not bad. Joe was looking at the latency. Not a lot. There was one latency issue, but nothing really worried about it. Just one of those spikes. But as he was looking at the errors, there are continuous errors. Joe scrolled down to see that particular dependency call, which is the remote operation purge queue, and Joe could see that all the way to the right, the error rates are spiking. Now, what did Joe do? Joe clicked on one of those faults to see what was happening, and he clicked on the trace ID. As the trace segmented path was coming up, Joe could see that the calls are coming in, but guess what? Something is happening on that third party, no, dependency call, not third party, but that dependency call. Joe scrolled down to see the segments, and all the way down, Joe could see that the SQS calls, there was some error. Joe clicked on that. Now he's looking for the exceptions. Joe went through the options and clicked on exceptions, and Joe could now immediately see that the purge queue operation is allowed once every 60 seconds. Obviously, the DevOps team tested everything, but before releasing to the production, they did not calculate for the, the volume of the operations and the volume of the purge queue operation. Now they should be tuning their SQS queue. Joe, now being able to figure out what exactly was happening in few clicks, he called the DevOps team and said that this is what you might want to do. Go and fix or update the purge queue operation in your SQS so that you would allow more than one purge operation. Joe felt relieved. Joe felt happy. Now it's the time for the coffee break, the much needed one. This is the third time that Joe really wanted to have that coffee. It's a Monday morning, right? Joe logged his computer and he was walking away. At that time, Joe's skip level manager called him and said that the company CTO's daughter was trying to book an appointment for her pet and she was not able to do so. Uh-uh, that's a problem. That's not nice. Joe has a bigger problem now to handle. You really don't want an unhappy CTO near your desk, right? Now, Joe was wondering. Joe was just now troubleshooting all the problem. Joe did not find an outage happening in his application because he was right there looking at the real-time data. Now, Joe was wondering, be the smart guy, is there a hidden customer impact that is not an outage yet? Now, Joe should be looking for the real end user monitoring data. What did he do? He clicked on CloudWatch, application signals, and this time he went to services again. The problem is the CTO's daughter was trying to book an appointment for her pet. This time, because it's the end user problem, Joe was looking at the pet clinic front end. He could see that there is something unhealthy on it. What did Joe do? Joe clicked on that particular service. This time, Joe needs to check the real user monitoring, and henceforth, he went to the client pages. And this is the real user monitoring data in application signals for you. And here you could see that the page loads, it's pretty good, nothing bad. The web vitals, all good. But what you could see is the Ajax errors, all these errors, it's consistently there. What are those? Joe did not expect that. Joe clicked on one of them. Now, as we have already seen, application signals focuses exactly on that point in time problem. And these are the traces for that point in time. Joe clicked on one of the traces. And as Joe was looking into the traces, Joe could immediately see that the calls are coming in pretty nice. There is nothing bad. Joe scrolled down to see the segments and he could see there is a 500 error. Joe clicked on that particular segment and now Joe is looking for the exceptions, if any. And Joe was looking at this and Joe was like, wow, this can't be true. His application with the latest release cannot schedule for a day which is 30 days into the future. Many of you might have experienced this, right? A faulty code in production because you simply cannot test every scenario in a QA ecosystem. And this one is a classic example. They tested everything, but not for a 30-day in future scheduling. And CTO's daughter in this case was trying to book an appointment for a date that is more than 30 days in the future. Joe felt like a superstar. He was able to find this problem in essentially like less than 4 clicks. Joe told his dev teams to make the necessary changes. Finally, Joe was happy and he was off to his much needed coffee. And guess what? Within a week, Joe got an email. It was end of that quarter and it simply said best employee of the quarter. Joe was happy. Our question to you is, while Joe was going through all of this, you are able to go from SLOs to services to service map, all of it automatically discovered for you with service diagnostics. I started by saying application signals in a single sentence means the ability to collect the golden metrics and traces for your applications, enabling you to quickly see and troubleshoot issues without writing custom code or even creating dashboards. Like Joe, do you want to be the superstar in your organization? And that is our question to all of you. As we wrap up or closer to the end of the session, we wanted to ask you a question. What does happiness mean to your customer? In order for you to dive deep and learn and then make sure that your organization is successful, we have some resources for you. And let's check it out what they are. The first one is called One Observability Workshop. This is aimed at providing a hands-on experience for you on the wide variety of AWS observability toolsets. It is a free of cost observability workshop for you if AWS hosts that for you. Please contact your AWS account team and they should be able to set that up for you. The next one, which is the observability best practices, is a best practices guide to learn more about the prescriptive guidance and recommendations with implementation examples. And we all are contributors to that. If you are a Terraform or a CDK shop, check AWS Observability Accelerator for Terraform, which is a set of Terraform modules and CDK modules to help you configure observability for your workloads with AWS Observability Services. The last time when I ran the Terraform Accelerator, it took me less than 15 minutes to set up the application as well as all the required dashboards. All of it less than 15 minutes. I would highly recommend you to test it out. Last but not least, check out the Skills Builder. You can enroll into our AWS Observability digital training course to build your skills and expertise pertaining to tracing, monitoring, and logging to help you observe and monitor your resources and applications on AWS. And this digital training contains presentations, architecture diagrams, service demonstrations, and whatnot. Please take a look at that. Now, as we wrap up, we all know that observability is the foundational element of establishing a reliable service. Now, the real ability to achieve highly available service is based on habits, paying attention to details, and being paranoid about what could go wrong. I personally would say that patience is virtue and there is no secret sauce. I would say that more than processes and procedures, what that matters is you and your experience. There is no compression algorithm for experience. We are here to help you on this journey. And it's a wrap from Lucy and Arun. Enjoy a good rest of the day. And back to you, Lucy, if you have any parting comments.
Awesome. Thanks, Arun, for the awesome demo. And I just want to say, poor Joe and the application signal saved the day. Again, I want to thank everybody your time. And if you have any questions about our presentation content, feel free to reach out to your AWS account team. We'll be happy to follow up and be in touch. Thanks, everybody. Have a great day.
Thank you.